Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge O Levels Physics 5054. So, today we are going to talk about stars and the universe. This is the name of the chapter, and we are going to work in this video on the sun as a star. You see, this is the topic which is newly added into the syllabus of the physics 5054, and it will be tested from the exams starting from the May-June 2023. So this chapter now is from a different book. This book is basically IGCSE physics book, and from here basically this is totally information, and there is very little to explain anything. So if there is some need to explain, I will explain, but basically it's a reading of that book. Okay, so it's kind of reading session. So stars and the universe, that's the main chapter. The topic of this video is the sun as a star. So the focus point will be know that the sun is a medium-sized star and describe its properties. Know that stars are powered by nuclear reactions that release energy, and these reactions involve the fusion of hydrogen into helium in stable stars. The sun is our closest star, and it is so bright that it banishes the darkness of space with its light. The radiation it emits comes from glowing hydrogen and provides energy for all life on the earth. The hydrogen is heated by the energy released in nuclear reactions in the sun's interior. In stable stars, these reactions involve the conversion of hydrogen into helium by nuclear fusion. Stars have several stages in their life cycle, and our sun is currently in its stable phase, which will last for a few more billion years. The sun is a medium-sized star which consists mainly of hydrogen and helium. The radiant energy it emits is mostly in the infrared, visible, and ultraviolet regions of the electromagnetic spectrum. This radiation is emitted from glowing hydrogen, which is heated by the energy released in nuclear reactions within the sun. Nuclear reactions in stars. Stars are powered by nuclear reactions. Stable stars such as our sun are hot and dense enough in their center or core for nuclear fusion of hydrogen into helium to occur. The high temperature in the core required to sustain the nuclear reaction is maintained by the large amount of energy released in the fusion process. The sun is powered by nuclear fusion. Some of the energy generated in the core is transferred to the outer layers of the star. These are cooler and less dense than the core, but are still hot enough for the hydrogen gas to glow and emit electromagnetic radiation into space. Stars vary in age, size, mass, surface temperature, color, and brightness. Color and brightness both depend on surface temperature, which in turn increases with the mass of the star. Stars that are white or blue are hotter and brighter, surface temperature of 6,000 to 25,000 degrees centigrade, than those that are red or yellow. Surface temperature will be 3,000 to 6,000 degrees centigrade. So I hope you understand this, and let's go to the next. So here we have the second subtopic, and these are stars. So the focus point in this topic will be know that galaxies consist of billions of stars. Know that the sun is a star in the Milky Way and that other stars in the Milky Way are much further away from Earth than the sun. Know that light years are used to measure astronomical distances and understand what is meant by a light year. Describe the life cycle of a star, including the terms protostar, stable star, red giant, and supergiant, planetary nebula, white dwarf star, supernova, and neutron star, and black hole. So these are the terms which we will be learning here. Okay, our sun lies in Milky Way galaxy that contains billions of stars far enough away that the light from even the nearest star takes 4 years to arrive. The most distant events observable today through ever more powerful telescopes occurred many millions of years ago. Observations of events both near and far have enabled astronomers to build up a picture of how stars form from the clouds of dust and gas in interstellar space, how they grow and evolve over millions of years, and how they eventually die, sometimes in a violent explosion such as a supernova in which their constituents are again scattered into space. In this section, you will learn about how stars are formed, how they are powered by nuclear fusion, and the life cycle of some low and high mass stars. The sun the sun is our closest star and is so bright that it banishes the darkness of space with its light. When the sun sets due to the rotation of the earth, the night sky is revealed. Away from light produced by humans, the night sky presents a magnificent sight with millions of visible stars. The night sky. The night sky has been an object of wonder and study since the earliest times. On a practical level, it provided our ancestors with a calendar, a clock, and a compass. On a theoretical level, it raised questions about the origin and nature of the universe and its future. In the last 100 years or so, technological advances have enabled much progress to be made in finding the answers and making sense of what we see. Although the stars may seem close on a dark night, in fact, the distances involved are enormous compared with the distances across our solar system. So great are they that we need a new unit of length, the light year. This is the distance traveled in the vacuum of space by light in 1 year. The star nearest to the solar system is Alpha Centauri, 4.31 light years away, which means the light arriving from it at the Earth today left 4.3 years ago. The pole star is 142 light years from Earth. The whole of the night sky we see is past history, and we will have to wait a long time to find out what is happening there right now. Light years 1 light year is the distance traveled in the vacuum of space by light in 1 year and equals nearly 10 million kilometers. 1 light year is equals to 9.5 expo 12 kilometer, or you can say 9.5 expo 15 meter. Galaxies. A galaxy is a large collection of stars. There are billions of stars in a galaxy. As well as containing stars, galaxies consist of clouds of gas, mostly hydrogen and dust. They move in space, many rotating as spiral disks like huge Catherine wheel with a dense central bulge. The Milky Way, the spiral galaxy to which our solar system belongs, can be seen on dark nights as a narrow band of light spread across the sky. Figure 6.2.1a. So here is one of the, if you want to see, I can increase the size. So this is the Milky Way. This is the Milky Way. So the key definitions here are the light year used to measure astronomical distances, the distance traveled in the vacuum of space by light in 1 year. The galaxy is made up of many billions of stars. Milky Way, the spiral galaxy to which our solar system belongs. The sun is a star in this galaxy, and other stars that make up this galaxy are much further away from the Earth than the sun is from the Earth. So this is the Milky Way. This is also an image of the Milky Way. An image of the Milky Way from a space prop, the Cosmic Background Explorer. This is the Milky Way. This is also the Milky Way. Okay. Origin of stars. When interstellar clouds of dust and gas containing hydrogen collapse under the force of gravitational attraction, a protostar is formed. As the mass of the protostar increases, its core temperature rises. Gravitational potential energy is transferred to kinetic energy as the protostar contracts under internal gravitational forces. When the core is hot enough, nuclear fusion can start. Hydrogen is converted into helium and a star is born. If the young star has a very large mass, it forms a blue or white star. If it has a smaller mass, such as our sun, it forms a yellow or red dwarf, and this is more common. So now we talk about the life cycle of the stars. In a stable star, such as our sun, the very strong forces of gravity pulling it inwards are balanced by the opposing forces trying to make it expand due to its extremely high temperature. This thermal pressure arises from the kinetic energy of the nuclei in the core. When the forces are balanced, the star is in a stable state, which may last for up to 10,000 million years. So, during which time most of the hydrogen in the core is converted to helium. When the star starts to run out of hydrogen as a fuel for nuclear reactions, it becomes unstable. There is less energy being produced by nuclear fusion to sustain the outward thermal pressure, and the core collapses inward under gravitational attraction. Gravitational potential energy is transferred to the kinetic energy so that the core becomes hotter. There is a fast burn up of the remaining hydrogen envelope in contrast to the core, and a huge expansion and subsequent cooling of the surface gases. The star turns into a red giant or red supergiant if the star is very massive. As the core heats up, its temperature becomes high enough for the nuclear fusion of helium into carbon to occur. This will happen to our sun, which is halfway through its stable phase in about 5,000 million years time from now. The inner planet Mercury will then be engulfed and life on Earth destroyed. The further stages in the life cycle of a star depends on its mass. So here we have a figure, you see. So let's talk about this figure. So a stable star, then it becomes a red giant. Then it depends, it's a low mass star or it's a high mass star. If it's a low mass star, it will convert into the planetary nebula with the white dwarf at center. Then it will convert into a white dwarf, and then it will convert into a black dwarf. If the mass of the star is high, so stable star will convert into red giant, then it will become supernova, and then a neutron star, or it can be a black hole. Okay, so low mass stars, what will happen with them? So that is our topic. So for the stars with the mass up to about 8 times that of our sun, when all the helium is used up, the core of the red giant collapses under its own gravity, and enough energy is released to cause the outer layers to be expelled. The small core becomes a white dwarf at the center of a glowing shell of ionized gas known as planetary nebula. Planetary nebulas are thought to play an important role in distributing elements formed in the star into the interstellar medium. They have been photographed from the Hubble Space Telescope, but have a short lifetime of about 10,000 years and appear to mark the transition of the red giant into a white dwarf. The white dwarf has a lifetime of about a billion years and eventually cools into a cold black dwarf consisting mainly of carbon. This will be the fate of our sun. White dwarf at the center of our planetary nebula. Okay, so we have what will happen with the high mass stars. Stars with a mass greater than that, about 8 times that of our sun, are hotter than the sun and use up their hydrogen more quickly. Their stable stage is shorter and may last for only about 100 million years. The core then collapses into a red supergiant, and nuclear fusion of helium into carbon occurs. When all the helium has been used up, the core collapses further under gravity and it becomes hot enough for the nuclear fusion of carbon into oxygen, nitrogen, and finally iron to occur. Nuclear fusion then stops and the energy of the star is released in a supernova explosion. In the explosion, there is a huge increase in the star's brightness, and the temperature becomes high enough for fusion of nuclei into many elements heavier than iron to occur. Material, including these heavy elements, is thrown into space as a nebula and becomes available for the formation of new stars and their associated planetary systems. The Crab Nebula is the remains of the supernova seen by Chinese astronomers on Earth in 1054. It is visible through a telescope as a hazy glow in the constellation Taurus. Figure 6.2.4 is an image of Crab Nebula taken by the Hubble Space Telescope. So we are talking about 6.2. Yeah, this is the Crab Nebula. I hope you can see this. This is the Crab Nebula. The center of the center of the supernova collapses to a very dense neutron star, which spins rapidly and acts as a pulsar, sending out pulses of radio waves. If the red giant is very massive, the remnant at the center of the supernova has such a large density that its gravitational field stops anything escaping from its surface, even light. This is a black hole. In a black hole, matter is packed so densely that the mass of the Earth would only occupy the volume of 1 cubic centimeter. Since neither matter nor radiation can escape from a black hole, we cannot see it directly. However, if nearby material, such as gas from a neighboring star, falls towards the black hole, intense X-ray radiations may be emitted, which alerts us to its presence. Objects believed to be massive black holes have been identified at the center of many spiral galaxies. So that's enough, and the rest of the thing we will do in another video. Watch this video again and again, because this is the academic language from that book, and I hope that if you watch it more and more, and you watch more videos from documentaries on the stars, their formation, their life cycle, you will be able to understand, imagine it, comprehend it better. So once again, I will say thank you very much. Keep watching my videos, keep learning, keep reading. Go to your library and find the books on the solar system and read those books. Watch my videos, watch documentaries from the YouTube, so you can master this concept. So thank you very much, everyone, for watching this video. Please like this video, share the link of this video onto your Facebook, Instagram, and Twitter accounts. And thank you very much. God bless you.